U.S. Navy warships designed to take battle damage, return fire, and stay in the fight. They can absorb incredible amounts of stress. Every system on board is held together in one way or another by the simple and ubiquitous nuts and bolts. The proper use of threaded fasteners is important in nearly any application, and in some, can make the difference between life and death. Hi, I'm Chris, and today we're going to talk about the nuts and bolts of nuts and bolts. Welcome back. Up to this point, we've been through 3 videos, a couple of them a little longer than I would have liked. But the whole point of this was teaching about threaded fasteners. We haven't even started tightening stuff yet, but finally, now in this 4th and final video, we're going to get to tightening. Again, I've got these 2 pieces of wood here, and I've got a nut into the vise to try to simulate a threaded hole instead of a nut and bolt. It's a little tricky because of my rudimentary setup here. But try to imagine that this top piece would be like a cylinder head or something that you're putting down, and the bottom piece would act as the block. Everything's cleaned, the fastener's good, you know you've done your checks and everything like that that we have talked about in the previous videos. You're ready to go and tighten it up. So to ensure that you have the best chance of providing the specified clamping force, there's a couple things that you need to watch out for. First, you want to make sure that your mating surfaces are clean. Make sure that there's no metal or anything pulled up around the hole, and there's not burrs or anything in there like we checked on the seating surface. On the bolt itself, you want to look at the same thing. The other thing I'll talk about is lubrication. Now the NSTM assumes that unless you're told otherwise, everything gets lubricated. There's a big discussion whether or not to lubricate. Lubrication changes the torque value a little bit. There's tables out there that you can find on the internet. There's different types of lubricants that change that torque value. I'm not going to get into it. I didn't use any lubricant when I was tightening my fasteners for the purposes of lubrication. The only stuff that I did use on some was anti-seize, and that was on suspension bolts and things like that where I didn't want the bolt to rust to the bushing, not so much that it was anti-seize for the nut and the bolt itself. Do your own research, decide on whether or not you want to use lubricant. I'm not going to really say anything else about it. So now you want to snug up all your fasteners. Doesn't really matter how you do this, you're not going for torque yet. And you want to ensure that as you snug it up, nothing's crooked or off or anything like that. Everything's nice and firmly seated. But again, you're just snugging it up here. So now once the fastener is snug, if you have a tightening sequence, now's the time to figure that out. If you're doing a cylinder head, the tech manual should give you a tightening sequence. Now you want to start to apply the torque. Now I'm only doing wood here obviously, so I set my torque wrench to 15 foot-pounds. I'm not even sure I'll get that out of it. But proper placement and use of the torque wrench obviously is very important. We spoke about that in the last video. You want to place a torque wrench on the head of the bolt or on the nut, depending on what you're doing. And you want it to be exactly parallel with the bolt. You want the handle of your torque wrench to be exactly perpendicular as much as you can to it. When you apply the torque, you want to apply counter torque. So you put your palm of your hand on top of the torque wrench head. That'll help keep it straight. Now you want to start tightening the fasteners down. Now you want to make, if you have multi-fasteners, especially on a cylinder head, you want to tighten them up a little bit at a time. So a good practice is to apply about 10% of the specified torque first to make sure that the parts are solidly together. All right, that feels like a little bit. You want to make sure that your parts aren't bent or crooked or anything like that. And then you want to apply your torque in about 25% increments all the way up to your rated torque. Almost. If you're 10 foot-pounds, 15 foot-pounds, whatever you're at, do the quick math in your head and make your way around if there's more than one fastener and apply it up into 25. Up to almost rated torque. Now in a previous video I talked about relaxation of the fasteners so that the fastener will tend to loosen up over time. Some of it's clamping force as the bearing surfaces all kind of fit together and the gaskets get collapsed and things like that. And this is the point where you're going to combat this. So first you bring your bolts up to within about 10 pounds of the final torque. So that you're going to have to find a agreement between the 25% increments and get within 10 pounds of the final torque. Once you get to that point, walk away, go grab a bite to eat, have a beer, something, give it about an hour. And what that's going to do is that's going to allow the gaskets to flex, the threads to begin to fit together, things like that, and allowing that relaxation to occur. And then once that's done, then you come in and bring the fastener to the final torque. If you had a tightening sequence and you went, opposites and all that kind of stuff, once you're all done and everything's tight, you want to go around again, but in the opposite sequence. So if you did 1, 2, 3, 4, something like that, you want to go 4, 3, 2, 1 and work yourself back, checking for proper applied torque. And that's just to make sure, again, that you've got an even load over everything. Another recommended feature, and again, this gets argued about, is checking the torque on the head. The NSTM says once the machine or whatever you did reaches normal operating temperature and it's run in a little bit, after it cools back down, you want to go around and check all your torques again. Do it in your tightening sequence if you had a tightening sequence. So now that the fastener's properly tightened, properly torqued, it shouldn't loosen under normal load, right? That was the whole design. A lot of time and effort went into making sure that you had it properly tightened. But sometimes we don't want a lot of preload on the fastener because the fastener needs to move, say like a door hinge or something like that. Or maybe it's a really, really critical joint and we want to make sure that there's no way that this thing is going to come apart. So there's a few things you can do to further prevent loosening without or in addition to preloading. Those are prevailing torque, which we've mentioned before, mechanical retention, or chemical retention. So we talked about prevailing torque in previous video, and that essentially was the amount of torque that's required to spin the nut on the threads of the bolt. That's prevailing torque. You can take advantage of prevailing torque where high clamping is not really required, like I mentioned, like in the hinge or something like that. So this is a nylock nut. There's a little band of nylon that's inside there, and as you get close to the end, eventually you get to the point where I can't tighten it anymore by hand. Obviously the prevailing torque now is going up quite a bit, but that friction that's created and that prevailing torque that's created there now prevents, hopefully, this fastener from coming apart. But if I have something that this fastener is holding together, but I want freedom of movement with that, that's where that prevailing torque gets taken advantage of. So the nylock nuts can be reused. There's a rule of thumb out there that says they can be reused about 5 times. The NSTM contains torque specs for prevailing torque based on the size of the nut that says whether or not you can reuse it. Essentially, my rule of thumb is you did your inspections like I pointed out before, as long as the inspection was fine, and when I put it on the nut or put it on the bolt, if I if I had to stop turning it because I wasn't strong enough to turn it anymore, then I considered it good enough for reuse. Now there's another type of prevailing torque fastener, and that's this guy right here. If you look at the circle, if I can get it in the camera right, you can kind of tell that it's not quite circular, that there's like 3 sides that seem to be a little bit flattened out. What this does is instead of using a nylon, this actually starts to deform the threads of the bolt. Obviously a little bit more invasive, not something you'd want to use if you ever want to take this thing apart again, because like I said, it will cause damage to the threads. Another mechanical means, this is a lock washer or a split washer. Obviously you can see that it's sprung a little bit and tight. As you tighten that down, it compresses it and it forces itself into the seating surfaces and the mating surfaces, and what that'll do is it tends to prevent loosening as those angled parts there kind of dig into the metal to prevent it from turning the other way. Another example, much like the lock washer, these are star washers, same kind of thing, and it essentially grabs on, it creates friction between the bottom of the nut and the seating surface, and it just tries to prevent loosening. Another example that you might see are called jam nuts. Now jam nuts are a little bit more confusing to use properly than you would think. This is not a proper example of a jam nut, but if you can imagine that this nut up at the top here is loose, and what you do is you take the other nut underneath of it, and you tighten it down, and the two fight each other, and it prevents any motion anymore. Again, I'm not going to get in how to use those properly. There are a couple instances, at least on my classic car, where jam nuts are used, but normally the nuts are not the same thickness, but that's beyond the scope for today. Some mechanical means of preventing the fasteners from loosening. Everybody probably recognizes this. This is a cotter pin. You'll find this especially in your front wheel bearings, usually used with a castellated nut. And this, goes through the castellated nut. There's a hole that's usually drilled into the stud or into the bolt. And then these, if you can see, it's two pieces here. The pieces get bent around. Again, this is something that you should do a little bit of your own research on if you're going to use that. Other things, there's regular pins that are usually like friction fit. Another thing you can use is lock wire. You can see this lock wire that's wrapped around here, and it goes through the holes that are in those nuts there. This is my steering coupler for my classic car. It goes from the steering wheel to the steering rack. You'd think they wouldn't make something so complicated, but they did. But those are lock wired together because obviously you want to keep your steering all the time. So the lock wire prevents those fasteners from loosening up. Another mechanical means are lock tabs. Here's a lock tab. It's still in the package. You can see that these little two tabs over here, they would get bent over on the one on the usually on the head of the bolt, and the other one on the piece of metal that you're attaching it to. This is for the emergency brake actuator that's underneath the car. So again, another critical component there that you don't want to lose control of. So that prevents just mechanical rotation and locks that thing in. The last type of locking is chemical locking. This here is Loctite Blue. The Loctite Blue is removable. There's another Loctite Red that's not. Won't really find too much of this stuff on the classic cars because the stuff really wasn't around too much back then. But if you ever get a piece of furniture or something like that and it's got nuts in there or bolts in there that you're putting together and you see this little colored circle on the threads, that's what that stuff is some chemical locking compound. Again, I won't get into the use of this. I did use it in a couple situations, but you have to do your own research and figure out if that's what you want to use. All right, last thing I'll talk about is thread protrusion. All thread protrusion is how many threads extend beyond the face of the bolt. When you're tightening the bolt down and you're done and it's as tight as it can be, you want to have at least one thread protruding. You need to have at least one. And what that does is guarantees that the entire seating surface and mating surface between or of the nut is in full contact everywhere on it with the bolt. Outside of that, there's not really any specification for too many threads. Normally the threshold is about 5, maybe up to 10. Anything beyond that, one, you risk damage to other stuff that's hanging out there, right? Who knows, walking by it, heck, you might hurt yourself walking by it. 2, it tells you that your bolt is probably not sized properly. If you've got that many threads sticking out, then your bolt is probably too long. Conversely, if you can't get enough thread impact where one sticks out, then your bolt's probably too short. So especially in a classic car, you may find that people just kind of go to their grab bag of bolts and have to replace a bolt, and they use some random size in there just so they can get it back together, and you see this thread protrusion, that's sticking out an inch or something like that. That's indicative that the right bolt is not in there, because I can tell you they didn't design it that way. All right, everybody, thanks so much for watching this series. A little bit longer than I was hoping it would be, but hopefully you learned something. I've included a link to the NSTM in the description. It's got a lot more information in there than I put out, so hopefully you can find something in there that you didn't know before. Thanks so much for watching. Cheers.